Hey everyone, welcome back. So in today's video, we are going to understand today Leetcode problem, right? Which is similar to study problem, right? So this is a daily contest problem and it's a hard type. But if you have aware with study problem, right? If you've gone through my previous video, you will be able to solve easily this problem, right? The concept is little change here that we will talk in this video. Okay. So I'll suggest please go and watch previous video that I have uploaded yesterday regarding this problem. Okay, so please go and watch. Okay, so let's understand in this video what the statement is saying. So the title is saying that find the original type string 2 and we have already uploaded type 1. Okay, so Alice is attempting to type a specific string on her computer. However, she tends to be clumsy and press a key for too long, resulting in a character being typed multiple times. You are given a string word which represent the final output display on the light screen. So you are also given a positive integer k, right? Then you have to return the total number of possible strings that Alice might have intended to type. But if she was trying to type a string of size at least k, so return the answer, but you have to take the modulo of 10 to the power 9 plus 7. So it will not exceed, right, the boundaries. So the given string we have given in the word is this, and k we have this, right? So the total number of possible strings possible is 5 as per the question saying, right? So these are the possible string that can be possible, that it's an original string that Alice tried to type it, right? Alice is typing a message, but she is clumsy and she sometimes hold down a key too long, right? When we are typing something in the keyboard, right? Similarly, she also do, right? But what she is doing when she types some keyword, right? She may holds down a key too long. So some letters get typed multiple times. Understand? For example, she want to type, let's suppose ABCD, right? Let's suppose, for example, but she was accidentally typed this string. Maybe this is the possibility that she wanted to type ABCD, but she accidentally typed what? This string AABBCCDD, right? We can say that. So we have given this word we have given. So this word is the final string that shown on her screen, right? On her computer screen, with the possible repeated character. We can say that, correct? Means there are A, B, B, C, C, D, D, like there is a repeated characters are there, right? Each characters are repeated here. We also have given k is equal to 7. What is k? K is the minimum length of string message that she intended to type, right? And so the problem is saying what are the possible string that she can try to implement, right? And what are the possible string that she tried to type? These are the possible string that is typed by her, maybe, and those are the possible string that we have to count and we have to return as answer. And it also saying we have to return the count, right? But we have to take the modulo 10 to the power 9 plus 7. Okay, means we have to return the count of such original string, and with respect to modulo 10 to the power 9 plus 7 we have to take. Okay, so let's understand this example. Okay, example 1, what we have given. So this example we have given is word, and k we have given 7, right? So what we should do, right? What we should do to implement to get the count. So let's suppose in the very first step, what we should do, we should group the same characters, right? Let's group the same character. Can we say that? Same chars. How we are going to do? So if this is a string, let's write the string as A, B, B, C, C, and D, D. This is nothing but a word, right? That we have given. Now we have to group it. How we are going to group it? Let's suppose if we will group, and the group can be, let's suppose we'll say A character we have how many times? 2 times we have, correct? Similarly we can say B we have how many times? 2 times we have, right? Similarly we can say C have how many times? 2 times, right? Multiply by 2. Okay, and then give me 1 second. Okay, and D we have is 2 times, correct? Means all these character we can group like this. So she may have held the key A, B, C, D, right, for a while. These are the possibility, and so this is became the group, same character group, right? And so we can say that she may have hold these key A, B, C, and D. We can say that, right? Now understand step 2. Step 2, what we should do, let's suppose what are the possible letters from the each string, right? We can say that let's take a possible original letters, right? We can say from each group. Can we say that? Can we say that? We can say that, right? Means each group of a repeated character can give us choices. What are the choices can be possible, right? So let's say it as a these are the possible groups are there, right? So from here we can get what? A, right? This because A held once or too long, right? Either she has pressed only one time, or maybe she has hold for long time, means she held for long time. Can we say that? We can say that, right? Similarly, the possible letters from BB is what? This is also another group. So we can say B, B, or BB. Okay, for here we have again or A. These are the possibility. Similarly, we can say for B, these are the possibility. We can say that one B, another is BB, another A, another AA. These are the possibility. Means each group of repeated character will give us a choice. Either it could be A or double A, or similarly B or double B. We can say that. Similarly, we can say for CC, right? The A we can say, and or we can say CC. Can we say that? Similarly for DD. We can say that. Yeah. Understand? Now think that what if we will multiply the choices? These are the choices, right? That is possible, right? So if we will multiply these choices, let's multiply the choices that we have given, right? How we will do that? So each group gives two choices, correct? A or AA, B or BB, C or CC, D or DD. Can we say that? Means each having two choices, means two combinations are there. Total two combinations each group gives here, right? So if we will say that, let's multiply how many choices are the possibilities are there. So each combinations, each groups gives two combinations, right? Total combinations. So if you multiply it, it become 4 to 16, right? 16 possible original string, right? These are the possible original strings are there, that is possible. Can we say that? Now it's time to filter only those. So we have total 16 choices we have, combinations we have, right? Out of which we have to filter only those with length greater than equal to 7. We can say greater than equal to 7, right? Okay, their length should be greater than equal to this. right? Are you with me? You're understanding, right? So let's think some of them. Let me clean this. Okay. Okay, let me clean this one also. So let's suppose give me 1 second. Okay, let's suppose that we are going to filter, right, only those whose length is greater than this, right, greater than equal to 7 or this, right? So let's filter the combination of string length should be greater than equal to k. It means we can say 7, which is given 7, right? Correct, we can say that. Now count only the original string of length 7 or more, right? So let's list few of them, right? Let's suppose the original string itself we have given. What other original strings are the possible strings are there? So let's see itself. We can say AA, BB, CC and DD, right? So what is the length is there? 2 to 4 6 8, total is 8. So this is valid, we can say that, correct? Then if we'll make a combination where we can write A, B, B, C, C, but there is only one D, we can say that. What is the length? 7. This is also possible, right? Now make a combination where we can take only one C, right? So possible string is A, B, B, 1 C and 2 times D. We can possible. 7 is there. This is also possible. Let's say another string where we can say B is only one time, right? So A, B, C, C, D, D. We can say this is also 7. This is also possible. Let's call this time for A, B, B, C, C, D, D. What is the length? 7, right? If apart from this, if I will do any other, means out of the 16, right? Out of the 16, only how many is this? 1, 2, 3, 4, 5. Only these 5 are having length greater than equal to 7, right? And that is why your answer is coming 7 here, right? So there will be 5 string whose length is greater than equal to 7, and that is why our answer is how many? 5 is there. So if you see this possible string, these are the possible string. Okay, now let's understand the code. Okay, so the very first we have to take the mod 10 to the power what 9 plus 7 we have to take, right? So we'll define the mod, right? And when we are returning our answer, right, at that time we have to take the modulo and we have to return, right? Like this we will do and we will return. Okay, so let's understand here. Very first we have given a word we have given and k we have given, right? So what we should do in the very first step is to compress the repeated character. Okay, what are the characters are given? Let's suppose we have given these characters, right, in the word, right? This is our word. So if we will convert this word and we'll compress each word, right, and we'll take the each character, repeated characters, right? What are the repeated character? So let's get the all the frequency of the each letters, right? So if you'll see, we have already seen these will be the how many groups will be possible. So each we will group by its repeated characters. So we'll compress the word into groups of repeated characters and it become 2 2 2 2 2. A is 2 times, B is 2 times, C is 2 times, D is 2 times, right? Now what we should do? So we'll take the first length of the word. Then we will define the frequency, right? So this frequency is a list of integer and this is a collections, right? So we'll take a array list in Java, right? And we'll use a frequency list, that is our array list, right? Now what we need to do, we'll take a count, we'll initialize a count as a 1, right? We'll traverse for all the all the index, right? Index will start from 1, right? And we'll check the current character and the last character, and then we'll update the count, right? Once the count is means what we are doing here, if it is repeated, let's suppose So this a is at where? At 1, and this a is where? I minus 1. I minus 1 is because we are starting I is equal to 1, so I minus 1 is what? 0. This is at 0, this is at 1, right? So these two will check where? At line number 12 we will check here. So each character char at I and char at I minus 1, the current one and the previous one is equal to, means both characters are same, just increase the count plus plus. So previously it was 1, now we have increased its count is 2. Next character is not a, so will not continue, count will not increase further, count is 2 itself. So we'll go to the else condition, right? Because the character is not matching. Now it is coming what? B is coming, right? When count is what? Count is 2. When count is 2, it will not go to this loop, right? Where it will go? In the else condition. So first of all, add into the frequency. So the frequency is 2 itself now, right? Only 2 value will be there, rest of the thing is not there, right? Because we are at I equal to 1, I equal to 2 we reached, right? So we will add those. Now reinitialize count as a 1, right? So that if the new character is coming, we'll start the count from 1 as we have done for here. Like that we will repeat it and we'll prepare the frequency map. Understand? So you have all the frequency count, right? You have all the groups, you can say you have all the groups ready of the repeated characters, right? Like that you have to add all the what we call the groups, right? Now what we need to do, we should compute the total possible combination. What are the total possible combination? How will you find it? So first of all, take a total combination, like total, what are the total ways is there, right? So if you want to compute the total possible combination, right, what we should do, so each group have a 2 character that gives you 2 choice, either take 1 or 2, like AA or A, B or BB, C or CC, D or DD, right? Those are there. So what we should do, so each character we have to take 2 choices, either 1 or 2. So total was giving what? 16, right? So what we need to do, just take the each frequency, right, and multiply with itself. It will come 16 here, right? We are increasing it, right, with the mod 10 to the power 9 plus 7, right? If it will increase, we will take that mod and it will, the total base will become what? The respective value that we will calculate through the mod, right? But 16 is a smaller value, so 16 will be here. Okay, I hope you understand the math, right? If you have any doubt, please ping me in the comment box. I will help you there. No need to worry. Okay, I'm here to help you, not to prepare the video. Okay, so let's understand here. Now in step 3, what we should do, just think that now you have all the total choices you have, right? Total ways you have, right? Total combinations, you know, right? 16 is the total combination. Since the group is, how many groups is there? Group is less than 7, which is less than k, we can say that, right? So we'll continue to the DP, right? And how we are going to define it? So we have to take the optimization concept. Let's suppose if group size is greater than equal to k, right, then return the total ways directly. We do not need to do anything, right? But if the group number of group is less than a, right, then we'll continue for the group DP. We'll continue for the DP. Okay, so we will take frequency size is 4 and it is greater than equal to what? K, that is 7. So 4 is not greater than 7 means it's wrong. 4 is less than k, right? It means it will not return the total ways. 16, it will not return the 16. It means we have to find the total possible length of the string, right, which is less than equal to 7. Remember that I have shown you the example, right? Currently I'm talking about this example that we have already got the 16 combinations, right? But now we have to filter all the strings that's length is greater than equal to 7, right? If it is less than equal to 7, we have to do what? We have to take the dynamic programming and then we have to find, right? But its size is not greater than equal to 7, right? So we will not have the count and we will not do these things, right? So now the concept begin for what? DP. So you will say, what does this DP does here? What is the use of this step 4, right? What we are doing here, why we are using DP? So in step 2, if you remember, right, in step 2, what we have done, we have calculated, we have already calculated, we can say, is total wage, right? We have calculated. So total wage is what? The product of all group size, right? Can we say that? Group sizes, correct? We have done what? 2 into 2 into 2 into 2 into 2, right? Like that we have done. We have got the 16, correct? Means we have already calculated this, right? So the step 2 gives us all the possible original string. That is, our value is 16. The total possible original string is what? 16, including the length. Either will take 1, right? The string of length 1 or string of length 2. Means either will take A or AA. Remember, B or BB, C or CC, D or DD. Can we say that? We have, means we have to see the length, right? But the string length of if we'll talk about K and greater than equal to K, correct? So these are the possible string that we have given here, right? Till here to here, or here, this or this. Means a string length is less than K, or length greater than this, length greater than 1 or greater than 2, right? Can we say that? Length greater than 1, length 1 we can say, or length 2, length greater than this, length greater than this, less than this and greater than this, we can say that, right? So if the string length is greater than equal to K, right, means it is fine, means we have calculated one, correct? That we have seen, right? Total was coming 5 was coming, right? 5 count was coming. When the string length is greater than equal to K, right, so we will get all the count and will return it. But the problem only wants the string of length at least what? K. Means the length, it is the problem saying that the length at least K, at least K, correct? So if the problem asking us only wants the string of length at least K, right, so we'll use the DP, right? So why we will use the DP? To count only the valid string whose length is what? Greater than equal to K. So we could find the total, all the possible string, right? And that we can do easily via multiplication, that we have seen, right? Or subtract only the invalid one whose length is less than this, right? If we can do that, we can find it easily, right? If we will subtract that, we can find. But here is a tricky part, that if we want to subtract the invalid ones of length having less than this, right, we can easily find. Or you can do the multiplication and you will find this, right? That the possibility is there. But if the length is greater than equal to K, right, means total possible string we can find, right? But we have to also subtract the invalid ones whose length is less than K. So what is the tricky part here? How do you count those string whose length is less than K, right? That's where we need DP to carefully, efficiently count all the combination of group selection that result in the short string, right, we can say. Understand? So imagine, give me 1 second. So let's imagine that each group is like a bag of choices, right? And we have a group of how many? 3, where you can take 1, 2 and 3. Either you take 1 or 2, 1, 2 or 3, correct? Means you have a group of items, you can say in a bag, right? There is a group, right? There is a, each group is, we can say, having item, right, in the bag, right? And you have the choices to take one or two or three, that kind of problem, right? So we need to find how many ways to pick item 1 from group 1, item 2 from group 2, right? Can we say that? So total will come how many? 3 ways, we can say that, right? Means if we want to find how many ways to pick one item from group 1 and how many, let's suppose I remember, like if we'll say, let's suppose, how many ways to pick one item from group 1, can we say that? Plus 2 items from group 2, correct? Let's suppose you can take 1, 2 or 3, right? Means 1 item from group 1 and 2 item from group 2, can we say that? So if you see how many, total is 3, total is how many? 3, right? And if we say how many ways you can pick 2 from group 1 plus 1 from group 2, how many? In this it will come, the total is 3, right? etc. Many possibility can be possible, right? There can be many possibility that we have to find either this way or this way, right? You understanding what I'm trying to say? I'm trying to say how many ways we have to find item 1 and item 2, right? So total is 3, and similarly we have in this 3. So there can be many possibility that we can find like that, right? So we are counting how many ways to reach length 0, 1, 2, k minus 1, right? Like that we can say that, right? By choosing the value from group size. That exactly what our DP will do in this video, okay? In this problem. So what our DP will track, right? Give me 1 second. What our DP will track, right? So DP will track this, we are calling the base cases we have, right? Means we'll take f at j, right? So this is nothing but our number of ways to make a string of length j, right? Of length j, okay? Number of ways to make the string of length j, and we need to start from where? At 0. F at 0 is 1, means there is one way to make an empty string. This is when we make an empty string. Then each group of size, let's suppose call s, having some size is there. So each group having size s, we can use DP to say from all the previous length, how many ways can I make a new lengths by adding 1 to s, right? Characters. So if the string s we have given, right? So how many ways I can make by adding 1 character in this string, right? So you have to find, you have to group it, right? For each, we have to group for all the group size we have given, right? For this, so if the size is s of the character, just will add 1, right? And so we will build up the count of the string. Let's suppose 1, 2, 3 till the k minus 1. Once you have, you know how many strings are too short, right? We can say whose length is k, right? Then you can subtract to get your answer, right? You know, if you know the count, right? Count is coming, let's suppose 11, right? You know the 11 is count whose length is too short, which is less than k, right? So total product was coming 16. 16 minus 11 is what? 5. Can we say that? Like that we will do and we'll implement it, okay? So let's understand further. So since the step since it is less than group size is less than k, we'll continue the dp here. Okay, so very first we will initialize these things, right? We have to initialize these things. We have to define that f at 1, f at 0 is 1 and the rest is 0. Can we say that? So if I represent this, so what I'm trying to do here, so initially we will define f at 1 is 0, that is our base case, and the rest of things, the prefix sum of f, we will define here. And so we have initialized these two things here, means f at 0 is 1, that is our base case, and then we have filled the array with 1. So that we will do here, right? So now what we will do, we'll process each character group using the dp and the prefix sum. Let's see how. So what we will do here, we'll process group one by one here in this loop, right? We'll process each group. So let's suppose in group 1 whose size is what? Size was 2, right? We can say that. So when the group 1, what are the groups are there? For a is 2 is a, b, c and d, right? These are the groups are there, right? We have the group a, b, c, d, right? And each group size is this we have given, right? So what we have for group 1, size is 2, correct? So we'll get the group size here, right? And we'll take the f at new, we'll take a new f we will find k, and we will update f at new, you can say j equal to sum of what? J minus group size to j minus 1. It means, let's suppose we have the f at new, f new at 1, we'll take from 1, right? We are taking from 1, right? So 1 at j is 1 and we'll go till the k, right? Means from 1 to, we'll go to until 7, right? Let's suppose 1 to 6, we'll go to 1 to 6, right? So what we will do, we'll take f new at 1 is nothing but what? j minus 1. What j minus 1 is g0, right? And we have already taken value is 1, correct? At each group prefix sum we have already taken, right? Then similarly at 1, what at not 1, at 2, in the next when j is equal to, when j is 1 and when j is 2, right? Then we'll define g at 1. We know g at 1 is also 1, right? So like that we have, and from let's suppose from 3 to 6, right? When j is from 3 to 6, we will fill what? 0, correct? Because 1 and 1 we have already 1 and 2 we have fixed, we have put, right? But from 3 to 6 is 0, right? So if we'll see the f we have now is what? We can say we have 0 1 1, because f at 1, f at 0 we have not taken anything, we have started with what? 1, right? So we'll say 1 1 and the rest is 0 0 0. Can we say that? And g we have, we know that is what? We have to update our g value was if we'll take the prefix sum after doing this, right? How we are going to see? If j minus group size minus 1 if greater than equal to 0, right? So we'll update our this value by taking this value, correct? And then we are, what we are doing, we are building the prefix sum from the new g new from f new, right? We have to do, right? So we have already seen that these things, right? Now we are building that. So what you are doing here, you are getting the value from where? G new, you are getting the value from here, correct? And then you are doing plus, you are taking the plus. If the mod it is increases the value, you are taking the mod, right? So g new is after the g new, right? You will update our g new, right? And then you will get what? You will update the f and g accordingly, right? You will update the group, right? It means you have the f is ready. Now you will get your g. How you will get the g value, right? Means 0, it is also 0, it will become 1, it will become 2 2 2 2, rest of the 2 is 2, right? 1 2 3 4 5 6, we can say, right? Like that we have to go. Understand? Means one more will go, I think. Yes. Okay, from 0 to 0 1 2 3 4 5 6. Yes, correct. Means we have to go like this, right? So each time you have to update this, right? And then once you have the value, right, you will update this value, right? Means you have to define your total prefix sum. So let me show you how we will do the further when the group sizes increases. Let's suppose this was from G1. Now for G2, what you will do? When G2 and size is also what? S is 2, correct? So similarly, you have to define f at new, right, from the when it will increase, right? You have to make for another group, right? So when I is 0, we have process for group 1, then we'll go for this is done, then we'll go for this one, right? Group 2. This also has the size same, so we'll define f new at 1, not for 1, we will go from j will get increased, right? We'll increase the j from 2, correct? Start from the 2, you will pass what 2 minus 1 g at 1, and the value is 1. Similarly, you define the at 3, right? The value will become what? G at 2 is nothing but 2, correct? And this g value will become what? Let me write at one place and then I'll show you. So now understand, this total group we have given is 4 group we have given. So we'll go for group 1, and we have prepared this one already, right? Then we'll go for group 2. The group 2 will have what? This value, right? So we'll update G1, G2 will get, and we'll update it, right? Then we have find f at 4, right? We have update like this, so we'll prepare like this, okay? Then we'll go for group 3, right? And this group 3 having the value will update each time, right? Means each time you will update the I will increase from where the next I will become, right? If you see here, I is starting from where? At 0, then it will go 1 2 3 4, right? As the group will increase, number of group, right? So when the group will start, so group we are starting from 1. For group 1 we are starting from 1, group 2 we are starting from 2, from group 3 starting from the 3, right? Just easy. And then you will get from group 4 for this one. So finally you will prepare your f and g, right? If you observe that, so total base we have given was 16 we have given, right? Now if you'll take g k minus 1 is what? G6 we are saying. What is we have given? Is 14 we have given. And result we have given what? 16 minus 14 is how many? Is 2, correct? So our result will become 2. But this contracts earlier example 5. That means you should count only strings of length equal to k, not greater than equal to k, right? If you are taking exactly k, right, exactly k, if you're counting string of length exactly k, right, not greater than equal to k, it counts how many strings have length less than k, and then we'll subtract, right? Which is correct as per our implementation. But some test cases you may need to confirm the boundary cases, and you have to also do what? Adjust depending on how g is defined here, right? Like that. Okay, so what we have done in this video, we have done very easy steps. We have done first, we have defined the group, right? We have compressed the each characters. Then we have defined our total ways, right? How many total ways are there? If its size is greater than equal to k, we'll return the total size. Otherwise we'll use the dp and we'll find the we can say invalid string whose length is less than k, right? And then finally you will return total ways k minus 1, and you will take the mode and you will return the answer. Okay, I hope you understand this video. If you have any doubt in this video, please ping me in the comment box. Okay, thank you guys, thank you for watching this video, and let me know if you have any doubt in this video. Thank you for watching this video.